So, guys, I'm going to explain these integrals. So, first we have the u substitution, right? I think last time when we met, we spoke about u substitution. So, remember, I said that when you come to u substitution, you gonna be given two functions most of the times, right? You're gonna be given two functions. When I'm given two functions like this, it should be that one should be simple to derive and the other one should be difficult to derive. For an instance, if we check this one, we realize that everyone can derive 2x. This one is simple. We all know everyone can derive 2x, but not everyone can derive an exponential function, right? So it means that when I come here, so I'm going to recognize and say that this one is simple. So I'm going to recognize my functions to realize if, okay, is this one simple or not? Don't you check or see that this one is difficult to derive? Obviously, this one is difficult. So on your substitution, you're going to focus on the one that is difficult to derive. So the one which is difficult to derive, you're going to go to it. You check. It's either, if it's an exponential function, it's either you choose the exponent. If it's not an exponential function, let's say it's a root, you're going to choose its inside. Or if it has brackets, you're going to choose its inside. Or yeah, I think for now we can focus on these three unless you come across a different question. So if it's like this, you're going to choose its inside. If it's an exponential function, you're going to choose its exponent to be u. You said it. For an example, if we check here, we did let the exponent of that exponential function to be u, which in this case we did let u to be equal to x squared. Then we derive this to give us du over dx, which is equal to, if I derive x squared, I get 2x, which is this, right? And again, I multiply both sides by dx, meaning I'm making du subject to the formula. Or I can just make the x subject to the formula, right? So if I make the x subject to the formula, I can just say that this is, I can just put it like this. I can just say that this is du over 2x is equal to dx. Right, from here I can just divide both sides by 2x. So I make dx with the formula. After that, I go back to the integral. I plug back. When I go back, we know that we have 2x e to the, we know that our x squared is the same thing as u, and our dx is the same thing as du over 2x. And the 2x will cancel out. When the 2x cancels out, we're going to be left with e to the u du. You see, right? Which is this. Now the integral becomes this. And we know that when we integrate this, we're going to get this. Then since it's an integral, we put plus c. So remember last time I said that every time after integrating, every time after you have removed these signs, that's when you can put plus c. Then if there are still those signs, you don't put plus c. So we integrate completely, then we put plus c. Right? So this was just a simple question. It means that we can look at the second one. So now let's come to the one of course. When we come to the one of course, we realize also that we're given two functions. The first function, which is not visible, it's 1, right? So we have 1 times cos of 3x. And we realize that between 1 and cos, obviously it's a cos that is difficult to derive. So I'm going to let its inside to be u. You see, right? When I let its inside to be u, so if I come now and say let u be equal to, let me see this, let u be equal to 3x, then I derive this, right? I get 3, and this implies that if I make the x with the formula, I'm just going to interchange the x and 3. I'm going to have this. Then I plug back, I'm going to have the integral of cos of u du over 3, because dx is equal to du. And this will be 1 over 3 integral of cos of u du. And the question is, what do we get when you integrate du? So that's where now we come and talk about these ones of integrating. Let's first, right? So let's talk about this cycle. I know that when I derive sine x, I get cos x. When I derive cos x, I get negative sine x. when I derive negative sine x, I get negative cos x. So what you can just do, what you can just easily do, you can just do this. You just write sine on top, you write sine below, you write cos here, you write cos, right? And then you do this. You can just ask yourself these questions, right? I know that when I derive sine x, I will get positive cos x. So it means that going this side, I can just derive. When I derive cos x, I get negative sine x. I can just put a negative there. And just know that after negative sine x will go negative cos x, right? So now I know that in this direction, I'm driving, right? So it means that for me to integrate, I must go in the opposite direction. I must go in the opposite direction for me to integrate. So now we know that when I integrate here, I'm integrating what? Cos u. When I integrate cos u, I must get sine. You see, right? So it means that here I'm going to get 1 over 3 sine u plus c. And what is our u? Our u is 3x. So I can just put 3x there. You said, and this is the solution. 1 over 3 sine 3x plus c. So it means that once you start to know that cycle, it's simple for you to check what do you get when you integrate negative sine x, what do you get when you integrate positive sine x, positive cos x, negative cos x, and so on. So it means that now we can check this one. We are given now the integral of 4x plus 1 all cubed dx. So as I said, we're always given two functions, which is one and this one. So I'm just going to pick this one, then let its inside be u. You see, when I let the inside be u, now I derive that, I get that this is equal to 4. Then I make the x with the formula, as I said. Then I go back to plug. If I go back to plug, I'm going to get this. Obviously, this is u. You see right now. And the x is the same thing as du over 4. Then I get this. Then I take out the 1 over 4 as a constant. Then I'm going to integrate this u to the 3. And the question is, how do we integrate u to the 3? We're going to say u 3 plus 1. Then we divide by that same exponent. Then we get u to the 4 over 4. Then I can substitute back my u. You see right now. So that's how we can solve this one. So it means that when we check, this was the third one. When we check the fourth one, we're going to have the same thing here. If we check this one, we have two functions. One is this one, the other one is this one. And this is the one that is difficult to derive. So I'm just going to pick its exponent because this is an exponential function. You said I'm just going to pick the exponent, let it be u. After letting the exponent be u, I'm going to derive it. The derivative is 2x. Then I make the x subject the formula. You see right now. So after making the x subject the formula, we can say this. Let me say this. We know that after for making the x subject the formula, I have to say x here. I divide both sides by 2x, right? And then I go back to substitute. When I go back to substitute, it means that since this is integral of x, I'm going to get integral of x e to the u du over 2x. Then this is going to cancel this. Then what I'm left with here is the same as this one. You see right? Then I take out the 1 over 2 as a constant. And we know that the integral of e to the u remains e to the u. That's how we get that solution. Hope we see that. Then I substitute back my u here on the exponent. Then that will be the case. Don't forget to add plus c every time after integrating. So now, if we check again, we have this one. Obviously, we're given two functions. The other one is this one and this one. So I'm going to let the one which is difficult to derive here. This one doesn't have any inside. So I'm just going to let it be u. You see right? I let that be u. Do the same thing. After that, you just derive, make the x with the formula, then go back to substitute. This is our u. And this one is du over 2. Then take out the 1 over 2. And always the integral of 1 over u, it's ln u. You see right now. And always put these ones, absolute values. Don't put this one. Because when you put this, you're saying that I don't know yet if this will be negative or positive. But what I know is that inside the ln, I must have positive digits. The moment I have negative ones, that becomes undefined. Anything equals to 0 or less than 0 becomes undefined. That's why I'm going to use ln u. Then I substitute back. Even though I have 2x plus 2 inside the ln, I'm just going to keep it as ln 2x plus u as the absolute values. We see right? Even if I come to this one, the integral of x squared sine x cubed, here I'm going to focus on the one which looks difficult to derive. Let its inside be u. You see right? And here's another thing. After deriving this, I'll get 3x squared. This one should always cancel this. The moment it can't cancel, it tells you maybe you should try by parts. You see right? If it doesn't cancel, it tells you maybe you should try by parts. So we're going to do the same thing. We just let that be u, make dx out of the formula. Then we know that when we plug back, the x squared is going to cancel the x squared. Obviously, this x squared, we should put it somewhere here for it to do that, right? And then when it cancels out, we're going to be left with sine this over 3. The 1 over 3 is taken outside. We know what do we get when we integrate positive sine x. Now remember here, if I have sine u, this will be negative cos u, cos u. When I'm integrating, I'm going back. So if I'm integrating positive sine u, I'm going to get negative cos u. That's why this is negative. You see right now. So the solution would be negative 1 over 3 cos of 3x plus c. The same thing goes here. You choose which one is difficult to derive. Same thing goes here. Obviously, it's simple. The one which is difficult to derive should be the one with which is including this one. You see right? Which is the cos. Difficult to derive. And then we come here again. The one which is difficult to derive is the sine. So I'm going to let its inside be u. We come again here. The one which is difficult to derive is this one. So usually here, we'll talk about this, right? This one is just a reason being check. This is not a u substitution. I just included it for at the end, you see, because it's bit. It's also u substitution, but this one is the one of trig, you see, right? So of the trig inverse. So when we come to this one, we realize that even if I was to let this inside be u, let's say I let u be equals to 1 minus 4x squared. If I derive this, I'm going to get minus 8x, but there's no x to cancel here. You see right now. So it means that it will be not appropriate for us to use u substitution, and also we couldn't use by parts here. So it means that we have to come to the one of trig, in the trig inverse. You see right. So we'll talk about this one when the time is right. So now when we come to by parts, with by parts we're going to be using Liat. We have to use Liat. With Liat, this one says that anything that comes first here, we should let it be u. This one is the log, the inverse. This one is the algebra. This is the trig. This is the exponential. You see right? Now when we check here, this is the algebra, the exponential. Which one comes first? It's the algebra. You see right? It means that the one that comes first, we're going to let it be u. So we're going to let x be u. That's why our x is u. And then we let dv be the remaining. So the formula that we're going to be working with here is the integral of u dv, which is also this by this. It's u by v. I just multiply those two minus, then I interchange them. Here, you say the integral of v du. The formula is that simple. Multiply them minus integral, you interchange them. So Now, since I know my x, I know what is my u, I know my dv, I'm just going to come here. Let's say now I have u. Let me write them here. Let's say I have my u is equal to x. I must derive it. When you derive it, you're going to get 1 times dx, right? Then now I know my dv is equal to e to the x. Let me check, was that e to the x, the other function, right? It's e to the x. Then I'm going to integrate it. Remember, this one goes with the x. When I integrate, usually I take this with the remaining. Remember what's remaining here after taking our u. What's remaining is the integral of ex dx. That is our dv. That entire thing, we're going to take it as our dv. So we'll take the integral of dv is equal to integral of e to the x. So this will be, when I integrate this, we know the integral of e to the x is e to the x. Then that will be our v. And the formula says this is the integral of u dv, which is equal to, I multiply those two minus the integral, I interchange them. Now it will be v du. So I can just substitute this. We know that our u is what? Our u is x. Our v is e to the x minus the integral, v is e to the x, and our du is equal to dx. And the integral of e to the x, we know that it's e to the x. Then I add c. So we're going to do the same thing for this one. This is algebra, this is trig. And according to Liat, algebra comes first. So let this be u, then let dv be equal to sine x. You see, right? So it means that we can compute this until we get the solution. So I think for now, I'll just stop here. Just try to understand the remaining so that when we meet next time, we try to do them.